All right, here's 3.3b. We're going to do some calculations involving slope. So in 3.3a, we kind of found a definition for slope, kind of what it is, how it relates to kind of real life, slope of ski slopes, slope of roofs, things like that. And we've got a calculation, we've got a definition as well. So we're going to go now and kind of use that definition. Oops, sorry. We're going to use that definition to do some calculations involving slope. So let's go past some of the stuff that we saw already. And here we are now. Oops, sorry. We're going to go right here. And here's where we cut off. And I'm going to say, let's calculate some slope. So here's right now, calculating slope. Let's calculate the slope of a line going through these points. There's 2, 1, and 3, 5. So there's one point, there's another point. Again, these are xy coordinates, so you have to kind of fit them into this pattern here because our definition of slope, slope m, equals y2 minus y1 over x2 minus x1. So the way that I kind of remember this is I say, well, you know what? I'm going to go x1, I'm going to go y1. And I'm going to go x2, and I'm going to go y2. And I'm going to say, you know what? Just for that point here, I'm going to call this my first point. And this is my second point. So that means that 2 is my x1 value. Y1 value is 1. X2 value is 3. Y2 value is 5. And you know what? If I put that right down there and I say, that's what I have to do to remember it, you know what? That's what I have to do to remember it. And it's not a bad thing. And all it is just means that, you know, it helps you to keep things kind of organized in your own mind. So let's find out what that slope is. Slope m equals change in y over change in x. Change in y is, well, 5, because this is, again, y2 minus y1. y2 is 5, minus y1 is 1, over x2 minus x1. x2 is, let's see, x2 is there, 3. x1 is 2. And this way, if you write these down here, x1, y1, x2, y2, you're not going to switch one of these, or switch one of these, or switch 5 and 3, or switch 5 and 1 without the 3 and 2 being changed. Because that way, you always just have to remember what the formula is, and then just plug in some numbers and do some calculations. So here is probably this whole thing here is going to be maybe the trickiest part of just calculating slope. There's going to be a couple more trickier points coming up, just because you can throw in some odd things with these numbers over here, but we'll tackle that in just a second. But for the most part, if you remember this, slope m equals y2 minus y1 over x2 minus x1, write these down, then you're going to have no problems. After this, it's just simply a matter of calculation. 5 minus 1 is 4, 3 minus 2 is 1, 4 over 1 is 4, and sure enough, there's our slope. Now what happens if, right down here, what happens if we would switch the names of point 1 and point 2 and say, you know what, how about this one? If I've got this one as my x1, y1, and this one is my x2, y2, I wonder if that would change anything, because, you know, we're flipping things around, so maybe that would change things. But let's figure it out. Slope m equals y2 minus y1 over x2 minus x1, and I encourage you to kind of repeat that every time you say it. Slope m equals y2 minus y1 over x2 minus x1. By the time you get through with this, if nothing else, this video and this homework, you'll have that pretty much memorized. So let's go through with y2 minus y1. What's y2? Let's see, y2, oh yeah, it's right there. y2 is 1. All right, 1 minus y1, y1 is 5, right there. Over x2, what's my x2? 2. Minus x1, what's my x1? 3. Alright, so now we've switched them around. Let's see what happens. 1 minus 5 is negative 4. 2 minus 3 is negative 1. Oh, hey, look at that. Negative 4 divided by negative 1. Negative divided by negative is positive. And 4 divided by 1 is 4. And sure enough, that slope is the same as that slope. So the kind of the bottom line about this blue calculation and the green calculation reinforces the fact that don't worry about which one should I pick as x1, which one is x2, as long as you're consistent with this one is my first point, so label it as x1, and this is y1, this is my second point, this is x2, and this is y2. Label them, so either the label in blue or the label in green, but be consistent with your second point and your first point, but it doesn't matter which point you choose as the first point. or the second point, as long as you're consistent with the numbering here, 1 and 1, 2 and 2, or 1 and 1, 2 and 2. As long as these subscripts are the same for this point, you're going to be okay. All right, so there's our calculation. Let's go through, you know what, I'm going to leave this one for you guys because we're kind of running a little bit longer on time. I'll leave that one for you. Calculate the slope, and by the time you come into class, I want you to calculate that slope. Show it to me as, what's my slope? Oh, slope m equals y2 minus y1, and this is what I want you to show me, over x2 minus x1. Show me that you've done this, and then plugged in numbers, and then gotten me some value, because we always want, for a slope, we always want to have a value. What's our number over here? Show it to me when you get to class. All right, so I'm going to kind of just talk about an overview of what we get for slopes. And oh, by the way, you know what? I'm going to give you the answer up here, but I want you to show me that you've gotten the answer up here. So calculate the slope. We should have a -3 up here. That value for that slope should be -3 for these 2 points over here. But I need you to show me how you got to that point right there, that slope. Show me this information. All right. If we're talking kind of qualitatively, because up here in the green calculation and these calculations back here, whoops, hang on a second, Control Z, there we go. All right, in these calculations back here on our first page that we talked about, we got a number here, that was 4. We got a number here, that was 4. It was the same. So we calculated, and we got a quantitative value for it. We got a quantity that tells me that the slope is 4. Up here, I got a calculation. I said the quantity is -3. Slope m is -3. But down here, we're going to talk about qualitative. In other words, we can have a positive slope, we can have a negative slope, we can have a zero slope, we can have an undefined slope. So let's talk about what these all look like in terms of a graph. So let's make our graph over here, and I'll say, you know what? For this, here's my graph, here's my graph. And we're going to kind of talk about what a positive slope, what a negative slope, what a zero slope, what an undefined slope looks like. So for a positive slope, we would have a positive change in x, over a positive change in y, or a negative change in x over a negative change in y. But in any case, sorry, that should be, oops, sorry. Change in y over change in x. Ooh, sorry about that. I'm glad you caught that. Thank you. All right. It would be a positive divided by positive. Gives me a positive number. So that would mean that if I start at some point, I'm just going to put an arbitrary point out here just to say, you know what does it mean? What does a positive slope mean? If I go a positive slope, positive change in y and a positive change in x, that means positive, and positive means that my next point is here. Or I can also say that for a positive, I can also have a negative change in y over a negative change in x. So my negative from here, my negative change in y would be going down this way, and my negative change in x would be going this way. So that would be a negative point, or that would be the next point as well. And sure enough, that would give me a slope that's positive. That means that I'm going forward in x and up in y, or up in y and forward to the right in x. So that is qualitatively what a positive slope looks like. Now, if we're talking about a negative slope, a negative sloped line would have a negative change in x, or sorry, negative change in y over a positive change in x. Or, let's start with this one. If I've got a negative slope, that would be a negative change in y over a negative change in x. Sorry, positive change in x. Negative change in y over a positive change in x. Or a positive change in y over a negative change in x. Because a positive divided by negative would give me a negative number, or a positive divided by negative would also give me a negative number. So you could have a slope like this. That would be a negative slope. And if you saw the green line like this, you'd say, oh, that has to have a negative slope. If you see a negative slope as a number, you'd have to say, oh, my line has got to look like my green line, going forward in x, but down kind of like a negative person. Forward in x, down in y. It's going to go look like this. So the negative slope is going to be like the green line. If we have a 0, let me change my pen color here. If we have a slope with a, if we have a line with a slope of 0, that means that our change, again, it's change in y over change in x. That would mean that that change in y has to be 0 over whatever change in x we have. Well, we'll just call it as a change in x. So if I start here at that same point, and if I move forward, my change in y means that I'm not going anywhere on this line because my change, this would be my change in y, but my change in y for a 0 slope is 0, so I'm not moving anywhere. And then I could change my x over here, or over here, or over here. Change in y would be 0, change in x would be over here, so all of a sudden my slope here, or my line with a 0 slope, looks like my red line right here that I've just created. And that's, if you think about that, that's kind of like a bunny hill. That's not, you know, what kind of slope is that? That's a 0 slope. Holy cow, that's got no slope on it at all. If we go to our black, our last color is black. If we go to an undefined slope, well, that means that we've got to do a little trickery here, and we've got to think a little bit more about it, because we've kind of done positive and positive, negative and negative, and we've done just the opposite, negative and positive, positive and negative. And here in red, we've done a 0 here. So the only thing left is to put a 0 in our denominator and say, well, if I've got a change in y over a change in x, which is 0, then that leads to an undefined slope. Only because dividing by 0 gives us an undefined value. So therefore, an undefined slope is dividing by 0. What does that mean? My change in x is 0. So let's start over here, just because I don't want to make it the same as this line here. If I start over here, just an arbitrary point out there, and I say, well, what's my change in y? Well, I can have my change in y be anything it wants to be. Let's just go up here. And what's my change in x? Change in x means it's no change in x, because it's 0, because we're saying that with a 0 in my denominator, that gives me the undefined slope. That's why we're changing in y some number, and we're changing in x 0. That means that this is our undefined slope. And the way you can think about that is going back to my ski story. If you're looking over your skis and you're saying, oh my gosh, that's not a slope, that is a cliff, you're saying that's undefined, so therefore that's undefined. That means undefined means dividing by 0, and our change in x is 0. So there's kind of a way to kind of qualitatively kind of look at an analysis of positive slope in blue, negative slope in green, 0 slope in red, and undefined slope in black. So there's a couple different qualitative looks at slopes.